Good to go. So lovely. I believe this is one of the hardest talks. Second day after lunch. Yes, most people will be sleeping, so don't hesitate. What's special about this talk is that the presenter Taner, as our good friend, he started mostly from our local events and from the J Professional events. So once again, how many of you have been to J Professionals? Yes, great. Next time, please more people to come. That means that the idea of J Professional is to raise new speakers, to help them get to the stage, to help them get experience for other great speakers. And that's what makes me really happy that finally Taner is on this stage of J Professionals. And he's going to talk about really important stuff, about the architectures. So I really want you to very warm welcome Taner.
Thank you. Okay, hello everyone. I hope the lunch wasn't too heavy, because this talk will be heavy for sure. But I'll try to not dive too deep into the details. We have a lot of things to cover, so yeah, let's continue. I want to talk about architectures in Java, which is something I'm really interested in. Can you see the mouse pointer? Okay. Wait. Yeah, which is something I'm really interested in, and I think it's not really talked that much, especially in the Java space. But yeah, we'll see. Okay, let's continue. So a few words about me. I am Taner Ilyazov. I work at Trading 212. I'm a Java geek, through and through, both in drinks and programming languages. I'm a productivity geek. I really love everything about tools and finicking with things to improve my way of working. And I'm a master procrastinator. So you can be sure the last slide I edited was 20 minutes ago. So, yep. Let's continue. I want to scope this presentation, and I want to say when these days architecture is a really big buzzword, because yeah, whenever you think of architecture, you start thinking about AWS, Kafka, RabbitMQ, message queues, and so on. Today, we're not going to talk about distributed systems. And we're not going to talk about the social aspect, which is, for example, the architect elevator. We're going to talk about the most pettiest form of architecture, which is, yeah, my most favorite. And that is, where do I put this freaking file? So, how many of you have inherited a Java code base that didn't really have an architecture? You don't really know where to put any files. You spent like 2 weeks onboarding just to get the sense of which features, where you work on them. Most of all, it looks like this. This is what you call, in these days, when someone thinks of a monolith architecture, this is what most people see, or most people imagine. This is a term coined like a lot of years ago, and it's called big ball of mud, which is when you don't really have any architecture, you just go with the flow and put all of the files, dependencies, wherever it's most convenient at the time. But when you don't really have an initial architecture, you can't really keep the same pace. Like initially, you have productivity because there is no technical depth at the beginning. So you're fast, you're pushing features, but then productivity slows down, maintainability becomes really bad. You can't really think about scalability because you can't even push features. And no one wants to work on this project because, yeah, it's very hard to get into. So the idea is, if you spend a bit initial time thinking about the overall structure of your application and where to put the freaking files, the curve won't really go that high in terms of cost of implementing a feature. but it will go in a steadier pace. That is what we win with microservices as well, but I won't bash microservices today. So, yep. So, yeah, let's see evolution of Java architectures. And the evolution goes like when we start with a project, we have just a single, we have multiple lines of code, so you just create a script. Then at a certain point, you start structuring the parts of code into methods. Then it grows to like 1,000 lines. You start thinking about files. Then you start thinking about packages. When you hit like some threshold of 50,000, then you say, OK, I need to separate into specific modules and then think about some organization because it starts getting really, really slow and really hard to work with in general. Is there anyone who hasn't seen this package structure? Like half a hand. Yeah, this is what I call the default architecture these days. Some would say this is the MVC architecture. For a long time, I thought it was called an MVC architecture, but no. MVC is something which touches upon really something else. Now, since we're at a Java conference, we're going to only talk about the common enterprise Java applications where we don't really parse and render the view code. So we don't parse the HTML, we just have APIs that the front end is calling. So this is called a layered architecture. It's also called n-tier architecture in some places. Most diagrams like this show it as like a 3 layers, but it can have a lot. The most I've seen in one project was we had 7 layers, which is all going down. So this is where we organize our layers by concern. So all of the controllers, we put them in the controller package. All of the business logic, we put them in the service package. The domain has our business classes. And we probably have like a repository package where we put all of the data access objects or, repositories. And what is really important here, as you see, the flow of control goes down. So the controllers are calling the business is calling the repositories and the data, and the infrastructure is all around. When I say the infrastructure is everywhere, what I mean is in the data layer where we should have like the core of our business, the data models, we have @entity by Spring, which is an infrastructure concern. It's not a part of the business domain. So this is how the structure looks like. We have a project, controller, services, repositories, models, and so on. And then, as with everything, in architecture we have trade-offs. This is simple and familiar. We have a clear separation of technical concerns. It's widely supported by frameworks, especially I think as much as I like Spring, even though most people don't like Spring. Layered architecture is a first-class citizens. They have all sorts of annotations which, for example, you don't really need to have a service if it's a component, but you have a service because it's easier for people if they just annotate something as a service and you know what to put there. This is really good for really small applications, but it has its trade-offs. The issue is domain logic is scattered across layers. So when it's scattered across layers, it's really hard to find all of the code that you need. So it's really easy to start duplicating code just because you can't really find something. You add something in one place and then you can't really find the other places where it's affecting because it starts getting really tangled at a certain point. And it often leads to anemic domain models, which means we have a domain where the classes don't really have any code. They're just carrier objects, which a lot of people have opinions on it, but I think some domain objects can also have business logic inside of them, because this, at a certain point, leads to huge services, really small controllers, and then really small domain models and a repository. So you basically bundle up everything in the service in general, and that's not nice. Integrity challenges that we have with this architecture is layer violations. So we said the flow of control should go from top to bottom. If we start calling from the domain the service, that's not really nice, because then we start going into not really following anything. And as one of my favorite theories, it's the broken window theory. When you see a violation in one place, you do another one, and then they start piling up. The service layer, as I said, it can blow up, it can become really big. And then, yeah, duplication, as I said. So let's continue. And then we have domain-centric architectures. Like when layered architectures, yeah, at a certain point, people said, we need to think about something else. We need to have a clear boundary and safeguard our domain, which is the core of our business. Like the technical advancements in our projects isn't what's making the money for the business. It's the domain problems that we are solving. So that is the thing that's core and it's most important. So there are a few architectures that their whole idea is to protect the domain. And there's an evolution which started in 2005 with the ports and adapters architecture by Alistair Cockburn. So the whole idea with this is you have a domain, which is the business logic at the center, so that's the heart. You have all of your business concerns there. You don't really have anything infrastructure related. The domain doesn't know anything about if you're using Kafka, if you're using whatever messaging service, and so on. And you communicate using ports. And then the technical concerns are in the adapters themselves. Let's look how this is possible. How can the domain not know how we're sending a message? So if we look at the layered architecture again, we see we have a user interface. The flow of control goes from left to right. We have the business logic, the data access layer. So in this case, when we want to persist something, the business logic calls the data access layer. So it knows about the technical concern of that we're using a database, for example, PostgreSQL. So what we do is we invert the arrow, we invert the dependency, where now the data access layer knows about the business logic, so it knows about the domain, the core. And the flow of control still goes from left to right. Normally, we have something like this when implementing these services, which are really CRUD heavy. We have the service calling some kind of a repository, and that repository is an interface in the data access layer. And the repository has an implementation, which is, again, in the same layer. So what we can do is we can move the interface. Move, please. Yeah, we can move the interface into the business domain, into the heart of our application. And then the implementation is in the repository. So what happens effectively is in the repository, we just have, for example, a method name, an interface, what we want to do. So send a message. And the business doesn't know anything else. The adapter knows about the business domain. It knows that we have a necessity of sending a message somehow. So in the data access layer, now we implement that using whatever messaging technology that we want. And then we can easily replace it without at all touching the business layer. That's the whole point. The point is, whenever we have a business concern, some kind of a feature, some kind of an implementation, we just do it in the core domain of our application. We don't touch the technical layers, so the outside layers. And then whenever we are changing our database, we just touch the data access layer. So in this scenario, the interface becomes the port, and the implementation becomes the adapter. If we look again at this, so now I think it becomes a bit more clear how the core, the domain, doesn't really know anything about the outside services. Something else that is really important about this architecture, we're separating the adapters into driving or primary adapters and driven adapters or secondary adapters. And the idea is the driving, the primary ones are the inputs into our application. That's the REST controllers. If we have a Kafka listener or something else, this is what's coming into the application. And we do whatever else. And the driven adapters are what is going to the outside, sending a message to someplace else or committing something to the database. The structure looks a bit like this. So instead of the controller, service, repository, model, and so on, we have an application. We have application or the domain. We have adapters. And then in the adapters, we implement like the input adapters, which is the web layer, for example, the controllers that's coming into the application, and the output ports are the persistent, the messaging, and so on. And in the heart, we just have the model. We have application services where we have the business logic, which is agnostic to the technical concerns. Again, we have some trade-offs. The good thing is now the domain logic is isolated from the technical concerns. This means, yeah, you can just have people working on the domain, and those people may not even be really good with technical databases, Kafkas, and so on. They're just really good with the business domain in general. And you can have teams who are working on the business. You can have teams who are working only on the technical details. And they don't even need to know that much about the internal business rules. This also means it's very testable. You can mock everything out from the external layers and just test your domain. It's easy to swap the infrastructure. You can, yeah, the idea was you can just swap out your database with some other database. You don't touch the domain at all. And technology decisions can be different. If you know you will need a database that needs to be very highly scalable, but now it's very costly to implement it initially out of the box, you can just use something else like SQLite. When you hit an issue, then you start migrating, and you can scale the features with the business and the technical layers independently. But too many interfaces, too much indirection can cause a lot of overhead. If we go a bit back here, you see the driving ports. No screen here. The driving ports is not really a good choice. I don't think anyone who actually uses hexagonal architecture uses the driving ports, because what that means is we have separate interfaces which just proxy to our domain, which just proxy to the services. So there's no point at all at that. So it's important to be pragmatic. I'll change the slide when the pictures are taken. Okay. We'll have nicer pictures. as trade-off. And then, yeah, it can be really excessive for small applications. This became, yeah, this is good when you have an application which is heavy. It's not just, okay, you get data, you write it to the database, get it out. The idea is to have applications which are really big in terms of business logic. That's why we're trying to safeguard it. And yeah, it requires a lot of more upfront design work. Integrity challenges here. You can have the domain code depending on the adapters because we need to deliver this tomorrow. We can't go through, create new abstractions and so on. So if you start breaking dependency rules, at a certain point, you will drift away. If you have adapters bypassing ports, again, won't be nice. So we can have a lot of things, a lot of issues that can just lead us back to the legacy effect. So then, in 2008, we have the Onion architecture by Jeffrey Palermo. And the idea is the same. The core of the business application is, again, in the middle. But now, instead of the hexagons, instead of the ports and adapters, we've just said push everything to the outside. They also call this like a concentric architecture. It's like a surface. The flow of control is from top to bottom. So presentation, persistence, infrastructure, the tests, it all depend on the application inside. And what he did is he said, okay, why not separate the domain services from the application services? Because it's nice when you say, okay, I want here only to have at the center the business logic, so I can talk through with like a product specialist and then talk through features. But we always have an orchestration kind of code where we need to jumble up separate features, and we need to know about concerns like sending events and so on. So we separate the application part, which is where we do the orchestration, from the domain. Another way this is visualized is like this. We have application services and we have domain services. So domain services can be mostly like the CRUD heavy applications. We have logic which is going to the database, creating an account, viewing an account, deleting an account, and so on. But when you have a feature, a use case which involves doing multiple operations over the business, then we push that out to the application services where we do orchestration. And then 2012, we have Clean Architecture by Uncle Bob, which kind of looks the same. And most people argue, I argue the same, that it is exactly the same thing. What Uncle Bob did is he used a bit more specific terms and so on to present the same idea. And I think this is the most popular out of all of the architectures after layered today. But yeah, idea is the same. If you say I use Onion architecture, you probably use clean as well. Clean sounds cleaner, so I prefer to say clean architecture. So yeah, same thing. And yeah, when we look at it, both the Onion and Clean, we go from the outside, so database, to the controllers, use cases, entities. The flow goes from outside the circle to the inside. He says we have enterprise business rules, which is very core specific, which is in the domain services, and we have application business rules, like when we're creating an account, but when do we notify some other service? When do we clean up something and so on? That's all orchestration code that goes to the application business rules. And he's saying we can play with the flow of control. we don't always have to go into the use cases, the entities, and so on. We can just skip through the database if we need something specific. There is a PHP guy, which is something really strange, because when I hear PHP, I think of legacy, I think of no architecture at all, but apparently they think about this stuff too. Is there any person here who writes PHP today? Almost all of you. No. So what he did is there is a link there which leads to a blog post. He has a series of blog posts going over all of these domain-centric architectures, and then he starts putting all of them together into this majestic diagram that you see. I would love to go into it, but we don't really have enough time, I think. So let's see the structure. The structure would look like this. With onion or clean, we can call our packages use cases, or we can separate them as application layer that has its services, it has its DTOs. We can have the domain package with the domain services and its specific models that we're going to work with, or data carrier objects, and the infrastructure, which is in the outside. And the domain doesn't know about the application doesn't know about the infrastructure, and so on. That's the idea. Again, trade-offs. For clean architecture, hexagonal, for all of these concentric ones, it's nice that the domain logic is isolated from the technical concerns. Business rules are testable. We're repeating the same thing with the hexagonal. Decisions can be deferred. We can swap things out. Overload of interfaces, but it's a steeper learning curve, because the more rules we put on the architecture, it's scarier for new developers to go in. It's scarier for people who have just worked with layered architectures to go in and want to do it. And it's very hard to keep the architecture in track and not let it drift away. It's excessive for simple code applications, as we said, and it requires discipline most of all, and people that care, that work on the project, so we keep it healthy. We have integration challenges, which are the same. We don't want abstractions to leak. We don't want circular dependencies between layers. In general, we don't want layers that we don't want dependency from the bottom layers to the upper layers. And when I say dependency, in this case, the dependency means even knowing about a file that exists in a different package. So just importing a file, that means we are depending on that specific layer. Then, I think 2018, someone had an idea. What if we organized our code around features or use cases directly? If we look again at layered architecture, we have presentation, application, domain, infrastructure. We say top to bottom. So why not just chop it off? And we have features that go from top to bottom, but they are split. So now, with vertical slice architecture, the idea is we just separate the whole feature into its own layered architecture inside. So all of the technical concerns are within the boundary of a single feature. So what we have is really smart, separate pieces of the code that it's very easy to go into. When you need to do a feature, when you need to create a new feature, you just create a new package, name it, create your controller service, whatever you need. We don't really care, we don't depend on the other services. That's the idea. yeah, this is called vertical slice architecture. We organize now the code not by technical concerns, but by business concerns. Each slice contains all of the code for one feature. Slices are independent from each other. Yeah, at certain point you will need to have like a shared module that all of the feature ones depend on it. You will have a core domain, but we need to keep it as small as possible. And it's very heavily inspired by CQRS principles. We can create separate DTOs just for creating an account and then extracting it. We can optimize for use case by use case without all of the technical depth from all of the other features that are going to make us do shortcuts. Yep, optimize for real-world change patterns. So this is how it would look. We have features, and then we have add product, place order, view product details. All of them are in separate packages. We have all of the files inside those packages. The slices don't know and don't depend on the other slices. We will need some kind of a shared kernel in the end. As I said, we need to keep it small. And who says we can't have a feature which is just a single file? I don't know if we can see. Can I do this? No. I can't zoom. Wait. No, can't zoom. So you see, this is a single file. If it's readable, we have the controllers inside, we have the command, we have handler, and everything about this feature is encapsulated into a single file. If the feature is small enough, you don't need to create all of the boilerplate controller services, domains, repositories, and so on. So we have very high cohesion, where cohesion means all of the code that relate and depend on each other are sitting in one place. They are not scattered across the application. We have easier onboarding. When you have a new developer, they can just go into a feature, see only 5 files. They work with that. They don't need to learn the whole database, take 2 weeks, and then introduce 5 bugs for the first feature that they're doing. We have reduced context switching. Since we have lowered the scope of the code that we need to look at when creating the features. They can evolve independently, so you can use separate, clearly separate patterns to implement any of the features. Fewer dependencies between teams. We can separate and we can say, okay, these features are for this team, the other features are for team Pechurki, and so on. When you have a layered architecture, it's a bit hard because when your team is growing, when the domain is growing, you don't know who works on what. So what we have normally is everyone works on everything, and we're all just making it hard for each other. So this is very nice to be able to segregate it. But we have a lot of code duplication. Since we're not going to depend when we're doing, for example, add product feature and then edit product feature, there will be a lot of code that will look the same. It can be the same. And that's not that bad. The issue becomes whenever you have something very core to your business, like if you have, as with trading 2 on 2, so you can have a lot of calculations that you need to do in one way. You need to do that calculation across multiple features. And when the formula for that changes, you need to go and change it across all of the features. So in cases like that where you have business logic which will be scattered across everywhere, this may be not the best choice. It's harder to enforce consistent patterns because one team can work in one way. They can use design patterns, follow solid principles, and so on. And then you can have just the tiger team mulling through and then implementing whatever comes to their mind at some point. cross-cutting concerns are hard to manage, and yeah, shared logic is bad. Integrity challenges. It's not. It's hard to not have coupling between the slices. The shared package can grow really bad, and if you grow a shared package too much, that may mean it's better to merge two features together, but then that feature can become too big and bloated and not follow the single responsibility principle. So yeah, watch out for that. And probably a lot of people now think, I think we cut to small chunks. So if we go back to layered architecture, where we had a controller service model, it's nice, it's simple. When we have all of the files in those three packages, when the file sizes grow inside a package, we always start introducing now, okay, we always have orders. So say order package, account package, products package, and these are repeated in all of our layers. So why not just inverse it and say the business terminology packages are at the start, and then the technical things are inside. This is also called screaming architecture, which was coined by Uncle Bob, I think 2013. Now the diagram would look like this. And the nice thing about this is, now who says we have to use layered architecture, or we need to keep a specific architecture in each module? So the orders team can use layered architecture, another team can use hexagonal, another team can use vertical slices. So depending on the use case, depending on the team that's working on a specific architecture, they can just choose, and yeah, there's complete freedom. So Conway's law is very easy to follow in here. This is what we call a modular monolith. I don't think anyone coined the term. Simon Brown is like the person who always comes to mind when you think about this, but there's not really a year or when of the term modular monolith. So it's a single deployment unit. And why I'm saying a single deployment unit is because a lot of the good things about working in microservices architecture, where you can separate teams to specific microservices, you separate your application to smaller chunks which fit in your head, as Dan North says. We can do it in here without paying the price of using microservices, like added latency, error handling, and everything. Modules can have clear boundaries. We can hide the internal implementation details. We can develop them independently. And it looks like this. We have the orders package. So this is a look into a single module. This is an architecture that is a bit harder to enforce, because you need to not give access to the other modules. So what we do is, inside a module, we define an API. If we need REST controllers, so an outside client to go inside, we will have an external controller, an external API, and then we have an internal API. The other modules will need to go through the internal API and ask for a product, ask for an order, ask for an audit, or whatever. And they can't see the services, the repositories, the model, or anything. They work with the DTOs as if it's a microservice that we're working with. So teams can actually own their data, they can safeguard their data. So multiple modules, again, would look like this. The APIs are the gateways into the specific modules. You will need to have a few shared modules, again, for cross-cutting concerns. But yeah, trade-offs again. We have very strong boundaries with explicit APIs. Teams can develop modules independently. The architectures, as we said, they can be very flexible. Teams can choose how they work, and they can just give specific only gateways into the application, and a very clear concern of business capabilities without slicing too deep. But modules need to be carefully considered, which is the same thing with microservices. The nice thing here is when we have not cut the business boundaries too well, and we want to merge them together, you can just drag and drop the files in IntelliJ, instead of taking 4 sprints to merge 2 microservices together. And at a certain point, if you need to scale, you can drag and drop into a separate Maven package, Gradle package, and you can deploy it as a separate microservices. This is a very good gateway into using microservices. But we have a lot of ceremony for cross-module communication. You need a lot of discipline to maintain this application. You need tools more than discipline. It's not suitable for small applications. Yeah, integrity challenges, cyclic dependencies is a very big no, like you have with Maven modules, like you have with microservices in general. We can still bypass that, but yeah, it's not nice. I'll speed up since we don't have too much time. This is, as I said, a very good choice if microservices is your goal, because you can have a very quick and fast iteration over your business as it's growing without needing to plan the whole domain and how to split it into microservices in 6 months. And you can just split as you go whenever it's necessary. There is a really nice implementation, or it's a very cool library which is by Spring. It's called Spring Monolith. It's in general availability from, I think, last year or the year before that, where out of the box you get a test which you call modules.verify, and then if you break the dependencies, if you have a cyclic dependency or whatever, the test will fail. So you automatically just safeguard the modules and internal dependencies. You have annotations like application module test, which separate your modules into specific contexts, so you can just deploy the orders module. You just deploy all of the Spring context for your orders module, and you test it independently. You don't need to boot up everything. But yeah, good intentions are not enough. If you just keep coding, architecture starts to drift. So we have ArcUnit, which is a really cool library, where the point is, it's a testing library. Spring Monolith uses it at its core. It has a very simple, readable Java DSL integrated with JUnit. The idea is you can enforce architecture rules at build time. And it's very flexible because you can define your rules and you can have exclusions as well. So let's look at some. The layered architecture would look like this. You say, we have our layers, and you can say the controller layer should not be dependent upon anyone. The service layer can only be accessed by the controllers, and so on and so forth. If you have cross-cutting concerns, you can ignore specific packages, ignore specific files from these rules. Onion architecture would look like this. Vertical slices would look like this. Modular monolith would look like this. This is a lot of typing. So Spring Monolith is really nice because you can just do modules.verify. But even without it, you can implement your dependencies like this. You can create annotations, and you can create rules on specific annotations. Like even if you just use layered, and people start putting things everywhere, you can have a rule in the service package. We can't put at entity, anything without entity annotation. You can say, okay, we can't have cyclic dependencies, and so on and so forth. It's very flexible. What you see in the end is something like this. You have a test failing where it says specifically why it's failing. You can add a reason about the test. So the junior developer, when their test fails, it can say, you can't depend from the service to the controller because this is the rule, and so on. And it becomes a living documentation. So we're running out of time. So let's conclude. There is no one-size-fits-all architecture. You need to make a choice. You need to see where you want to go, and so on. Intentions are not enough. You need to leverage tooling like ArcUnit. You can use Maven modules to do clear separate layers, and then you have a compile time failures when you try to depend on something from the outer layer because you don't depend on it. But it's not really that flexible. You need discipline, we need shared understanding, documentation, and onboarding people with the architecture. And we need to be pragmatic most of all, because if you start just following hexagonal architecture and start making interfaces everywhere, but you will never replace the database since it's just a 1-month project, then it just becomes too much administrative maintenance work. And most of all, architectures should change with the business requirements that are changing, with the technical requirements that are changing. Don't just start with an idea and then 10 years later keep on doing that same idea. It should evolve. And I'll conclude with this quote. Legacy code is not about software, it's about people. When you work with a monolith, it doesn't mean you work with a big ball of mud, as you say. And all of these rules, you can implement them in a microservice. You can have a float of big balls of mud, or you can have cleanly architected microservices or monoliths, whatever. And that's it. Thank you.